So let us discuss the next agendas of Laplace transforms. See, I'm not getting into the detail of this chapter because in GATE it is not very important, number one, in engineering maths portion. But and you will also study this subject or this topic in your other subjects, in your respective technical subjects also. So I'm just being very much concerned till the Laplace finding out and the inverse of that particular thing. Still, we'll discuss a couple of properties of Laplace here. Properties. Number one property is linearity. Linearity. What does linearity property say? Is that, for example, if I have a Laplace of a function ft, a times ft I have taken, plus b times gt, let's say, right? I have a function like this, or I have a time domain signal like this. I want to find the Laplace. So this can be written as Laplace of a of ft individually plus Laplace of b of gt individually, right? So this is basically the meaning of linearity property. We can prove it very easily. This can be done, right? Substitute everything in your basic definition of Laplace. What was the basic definition of Laplace of ft? Basic definition was, it is nothing but f of s, or we call it integration 0 to infinity e raised to minus st, the kernel, into ft dt. So if you substitute this ft and you will solve it, this is the basics. In any game you say it is stick to the basics. So in GATE examination also I will say stick to the basics. Wherever you feel stuck, stick to the basics. You will get your answers. And one more property I would like to discuss here is called as shifting property. Shifting property. What is this shifting property? Let us understand. Let's say if f of t has a Laplace equal to f of s, then Laplace of e raised to at ft, if I multiply the signal by e raised to at signal, or maybe whatever you call it as a function, then it will be equal Laplace of f of s minus a. How will you prove this thing? It's very easy again. I'll just show you. I have not shown you the proof earlier also, but I'll show you here. Let us prove this. Prove. What I'm saying is Laplace of e raised to at. I'm talking about LHS, left hand side of ft. So from, let's say, basic definition of Laplace, we know that Laplace of f of t, whatever comes under this bracket, is nothing but integration 0 to infinity e raised to minus st into whatever was this in bracket. I'll write it ft dt, right? So similarly, when we are talking about Laplace of e raised to at ft, so this is nothing but 0 to infinity e raised to minus st into, instead of this ft, what I will write is, I will write it e raised to at f of t dt, right? Now in this I can write it down 0 to infinity. Can I say, if I take e, this is also e, this is also e, in between you have multiplication sign, so I will take minus s common, so it is s minus a t f of t dt, right? Now what is this expression? I have replaced s with s minus a, so can I say this is nothing but Fourier transform of s minus a, isn't it? Right? So you can see e raised to at f of t has been written as this. So hence proved, right? So easily you can prove this particular type of examples, right? Now you can solve a couple of problems on this particular thing directly or indirectly. You will get the questions, right? Inverse Laplace also we have already discussed how to find out inverse Laplace, right? For example, if I say find inverse Laplace of 1 by s minus a, so it is very simple. It will be nothing but L inverse of 1 upon s minus a. That is nothing but e raised to 80, because I know Laplace of e raised to 80 is 1 upon s minus a. So that becomes very simple for us to understand, right? Let us solve one question which came in GATE exam in 2010. The question was find the inverse Laplace transform of the function ft is equals to 1 upon s square into s plus 1. Sorry, this is not ft, it is fs, right? So you need to find out ft, basically find ft. So that is basically written find inverse Laplace transform. Options given to you were t minus 1 plus e raised to minus 1, t plus 1 plus e raised to minus 1, minus 1 plus e raised to minus 1, 2t plus e raised to t. Now when you solve it, you want ft, you basically want ft, right? Now when you talk about ft, so ft is nothing but Laplace inverse of the given module, that is 1 upon s square plus s plus 1, sorry, not plus, into, right? So if I use partial fractions here, we can use partial fractions. Yes, how will it look like? It will be nothing but a upon s plus b upon s square plus c upon s plus a. Now when I solve this, 1 upon s square into s plus a is equal to as into s plus a plus b times s plus a plus c times s square upon s square into s plus a, right? So when we match coefficients, you will find that a plus c is equals to 0, a plus b again comes out to be 0, and directly we can see b is equals to 1. So solving all the given values, what we'll get is a is equals to minus 1, b is equals to 1, and c is equals to 1. So ft basically, now I can recognize ft now, right? Ft will basically become L inverse of minus 1 by s plus 1 by s square plus 1 upon s plus 1, right? So this can be basically written as, now here we can use linearity property. This is minus 1 by s means minus you can take common. So you can say minus 1, sorry, you can individually get the inverse. L1 of minus 1 of 1 by s plus Laplace inverse of 1 by s square plus Laplace inverse of 1 by s plus 1, right? So if you get these particular things, you will win the game. How? Let me explain. So simple, this will 1 by Laplace inverse 1 by s is 1. So it is minus 1 plus t plus e raised to minus t. Simply. So if I rearrange according to the options, t minus 1 plus e raised to minus t. Which option? Option A. That is how you could have got a mark in GATE 2010, right? Clear? So these are the types of stuff which can be asked. Now there are 2-3 concepts which are given in your booklets also, but they are not important in terms of engineering maths is concerned. Like convolution. Convolution basically you study in your signal and systems, right? So it is not a topic for mechanical basically. It is for electronics, electrical student, instrumentation students, because that is purely into signal and system. So you'll study that in detail there. So I'm not discussing convolution here, right? Similarly, time shifting, time scaling, nothing has been discussed here. Couple of things which I may mention here is what we have discussed till now is frequency shifting, right? What we shifted was, let us talk about certain things like we already discussed about this frequency shifting. Now what is this frequency shifting? For example, we have said Laplace of e raised to at ft. What it will become? F of s minus a. We shifted the frequency by a. Similarly, if it was Laplace of e raised to minus at ft, it would have become f of s plus a, right? Similarly, sometimes you may also encounter something called as time shifting. Just remember these as results. Don't get into the nitty-gritties how they are coming. You will study in your respective subject. I'm just telling you. Sometimes you may encounter t minus, let's say t naught. This is shifting in time domain. So in frequency domain, it will become e raised to minus stfs, because the formulas are just the opposite. Right? This is called as time shifting. If you shift the time, you will have a factor of e raised to minus st. Similarly, differentiation in time domain. What effect it will give? You will see if I say Laplace of d by dt of ft, d by dt of ft. This is nothing but s times f of s minus f of 0 if there was some initial conditions, right? So I can say that in differentiation in time domain, I am talking about time domain. You will say differentiation. So the effect is multiplication by multiply by s in frequency domain. Clear? So this we have to remember, right? Similarly, see, differentiation and integrations are counter effects. So integration effect, so integration in time domain, what is integration in time domain? Laplace of integration of ft dt is going to give you fs by s. So basically this is nothing but integration in time domain. What you can say is again time domain and frequency domain. So in time domain, if you are saying it is integration, so in frequency domain it is giving you a counter effect. That is what it is giving you, divide by s. Clear? So these are certain things which you have to understand, digest, and get it done, right? Then one more thing I would like to discuss here is initial value theorem. Initial value theorem. What is initial value theorem? Let's say if ft and its derivative are Laplace transformable, are Laplace transformable. That means Laplace is possible, right? There are certain functions whose Laplace is not possible. So that is why this condition is mentioned. Then limit t tends to 0. Initial condition is 0. ft will be equal to limit. We convert it to s domain. So s tends to infinity. Then if time is 0, s tends to infinity into s of fs. This is called as initial value theorem. This is very important, right? Similarly, you can also have a final value theorem. What is final value theorem? This limit will change to infinity because you are talking about final value. So this limit will change to 0. That is the only change you will find in final value theorem. Clear? And you can have convolution, and you can have periodic functions, Laplace, a lot of things. But I'm not getting into the detail. I have already told you I'm not getting into the detail because you will get this thing in your respective subjects. You can try questions. You'll be able to solve questions easily with this particular fundamental knowledge which you have got in this Laplace transform. Okay. Thank you.